Okay, so let's give you guys another random integration problem. So somehow integrate this. So press pause and have a go. Okay, so to do this, this in a way is like a polynomial over another polynomial. So remember this. If you have a polynomial over another one, and then you're trying to integrate it, remember we had a set of rules where you can follow in order to integrate this. We could use long division, um, but before you expend your energy into using long division, try to see if you can factorize this, because you might get lucky and it might cancel out with this. So before you expend energy into using long division, try to see if you can factorize this. So let's try and factorize this. So your eyes should zoom into this 5. Two numbers multiply together to give you a 5. Well, it can be a 5 and a 1. That's pretty much it. And then the next part is to look at this. Um, uh, this plus here would imply that either it's a positive 5 or positive 5 and a positive 1, or a negative 5 and a negative 1. Well, the next thing you should look at is this thing here. There's no way you can create a negative 4 from here or from here, because this will give you negative 6x. This here would give you positive 6x. And this plus here would mean that you had to have a plus and a plus, or a negative and a negative. In short, you can't really factorize this. So we can't factorize it. So let's try and complete the square. And as it turns out, you can complete the square on this. If you complete the square on this, it will give you this. Hang on. So to complete the square, it will be x, and it's always going to be half of this. So minus 2 squared, and then you take away the rubbish here, which will be negative 2 squared will be 4. You take away that rubbish, and then you carry this thing down. So completing the square here would then give you this. And then if you look at this, this is almost exactly the same as this. So make the adjustments on this. So rewrite this as this. Hang on. Rewrite it as this. So this thing here. So rewrite this. Hang on. Looking at this here, we can always rewrite it as negative 2 and then plus 1. So this would then be exactly the same as this. Well, anyway, rewrite this bit here as this, and then you can see that this would then be exactly the same as this. Okay, so once you're here, then split up the fraction. Here you've got one fraction. Split it up into two fractions. So here is one fraction, and then the other fraction being this. So you got your 1 here, 1 here. So split this into two fractions. So that will then give you one fraction plus another fraction. And then if you look at this here, this exactly the same. So it kind of makes sense to use substitution. Let u be this thing here. So let u. So we can put this into here. We can put the u into here. We can put the u into here. If u equals this, then du equals dx. So this whole thing here will then becomes a lot simpler. It will become this fraction plus this fraction, and then you've got your du. Okay. So now to integrate this, just remember that when you differentiate inverse of tan, it will then give you this. So if I were to give you this, then if you integrate it, then it will give you the inverse tan of, in this case, u. So to integrate this, it would be inverse tan of u. And then looking at this here, try to keep an eye. Remember, when you're integrating, always try and keep an eye out on something being the exact derivative of another thing. Well, this thing here is pretty much almost the exact derivative of the second bubble. So if I were to give you this, differentiate natural log of this, whatever this bubble may be, if you were to differentiate this, it would be 1 over the complicated bubble, this bubble here, and then you've got to times the derivative of the bubble itself. So it will give you this. You see, to integrate this, if I were to give you this natural log of the bubble, which happens, if I were to give you this, and ask you to differentiate it, it would then give you 1 over the bubble, which happens to be u squared plus 1, and then you've got to times with the derivative of the bubble itself, which will be just 2u. You see, this u here matches up with this u here. The only difference is that you need to make the adjustment on this 2 here. So the adjustment we should make to our initial guess should be a half. You see, if you differentiate this, it will then give you this thing here. So when you integrate this, it will be this. It will be a half of that complicated bubble here. Well, from here, hang on. From here, if you integrate this thing here, it will then give you this. And then earlier we said u was x minus 2, I think. Earlier we said u equals x minus 2. So put the earlier we said u equals x minus 2. So we can put this thing back into here and then back into here. So this here is your final answer. Okay.